So here I'll discuss continuity. So first I will explain what exactly the meaning of continuity. So whenever you have a function fx and you are going to check the continuity at some point m, so there you have to see, like at that point m, whether the graph has interruption or any gap. Then if there will be gap or interruption, then that function fx will not be continuous. Okay, and if there is no interruption, no gap, then it will be continuous. Let's see it with a graph. Okay, so suppose you have a graph, something like this, and this is the point. Here we have taken the point, this is the point m, and this is fx, and so this function fx at this point m has no interruption. There is no interruption and also there is no gap at that point. So we can say that this fx will be continuous at m. Now let's take another example. Suppose we have this graph, okay, here and here. This is the graph of fx, and this point here, this point is m. So at this point m, you can see there is a interruption, there is a gap. At this point there is a gap, so that means this function fx is not continuous at this point m. So basically this is the meaning. So from the graph only you can see whether the function is continuous or not. Now for checking, this thing you have learned in your previous classes as well, that if the left hand limit is equal to the right hand limit, and that is equals to fm. Suppose we are finding the continuity at point m, so you have to check the left hand limit at m and also the right hand limit at m. That should be equals to fm. So if these three values are equal, then the function will be continuous, otherwise it will be discontinuous. So that thing you have to see for continuity. Now let's see it with an example. So suppose you have y equals to x square minus 4, where your x is can be all the real numbers. Now for this function, let's draw a graph. So here's the graph. So this is like a parabola, and the vertex will be here, and the points are minus 2, 0 and 2, 0 are the points on the x-axis. So now you can see in this graph there is no hole or there is no interruption. Okay, so this function or this y will be continuous at all the values of x. Now see some more examples. Now here I have taken another example. Fx is x plus 1 when your x is greater or equals to 0, and it is x minus 3 when x is less than 0. So now we will check the continuity of this function. Okay, so let's draw the graph for this. So here you can see the graph. So you can see the graph when the values of x will be greater or equals to 0, that time this will be the graph y equals to x plus 1. This is the function. And if the values are less than 0, then your graph will be this y equals to x minus 3. Now we have to check whether it is continuous or not. So you can see in this graph, if the values are greater to 0, then this is the function, okay, and there is no gap or no interruption in this line. Okay, so it will be continuous for all the values which are greater than 0. Okay, now if we'll see this one, so here also there is no interruption, no gaps, so this y equals to x minus 3 is also continuous for all the values which are less than 0. But what about 0? Okay, now see the at 0, here you can see a big gap between these two graphs or these two lines. So here you can say that this function will be discontinuous at x equals to 0. Okay, now let's see how can we write all these things. So as you have seen, so you can write that fx, you can simply write it fx is continuous for x greater to 0 and x less than 0. Why? Because for all these values, this left hand limit will be equals to right hand limit, and that will be equals to fx, okay, where your x is greater to 0 and also x is less than 0, okay, because only one function is valid. For greater to 0, only this function is valid, so whatever the value you will take in the left side, right side, and also fc, that will be same, okay. We can see it with this also. So fc will be c plus 1 for all c greater to 0, and also c fc, I'll take another example, fa will be a minus 3 for all c less than 0, okay. So this will be continuous for all these values. Now we will write it for x equals to 0. Now we will see the left hand limit, okay. So at 0, so which function will be valid at that time? When x is less than 0, then this function will be valid. So you will write x minus 3. So here what we will get, 0 minus 3 will get minus 3, okay. So now check out our right hand limit. So right hand limit, which function will be valid? X will be just a little bit greater than 0, so that time your x will be this function, that is x plus 1. So here it will be x plus 1. So now if you will put the value 0 here, so you will get 1. So now you have seen that left hand limit is not equals to right hand limit, okay. And also we have to find out f0. So what will be the value of f0? f0 is when x is 0, then only this function is valid, x plus 1. So at f0 it will be 0 plus 1. So that is not equals to f0. So here you have seen at x equals to 0, the left hand limit is not equals to right hand limit, and also it's not equal to f0. So fx is discontinuous at x equals to 0. Okay, so and also this point is known as point of discontinuity. So this point is also known as point of discontinuity. So you have seen this function is continuous at all the points. So x equals to 0 is point of discontinuity. At all the other points it's continuous, and only at 0 it is discontinuous. So like this only you will solve the questions. Now here the important point that some of the students might forget, that you have to find out left hand limit, right hand limit, and also you have to make it equals to f0 to prove whether it is continuous, okay. So if any of these is not coming equal, then it will be discontinuous.